Welcome back to Practical PyTorch. Last time you built the full training loop, the 5 steps that make a model learn. Now you put every piece together. We fit a line to data with nothing but tensors and that loop. This is the payoff. You have met every piece already. Tensors, autograd, a loss, an optimizer, and the training loop. Now we put them together into one real model. We fit a line with nothing but tensors. No nn.Module, no DataLoader. The parameters are 2 plain tensors, and the line snaps onto the points as the loss falls. This video has 4 parts. First, the model is just 2 tensors, W and B. Second, the whole program. The data, the parameters, and the 5-step loop. Third, we watch the line fit. Bad, then better, then fitted. And fourth, reading a falling loss. When has it converged? First, the model. It is just 2 tensors. This is our data, 12 noisy points. They trend upward from the bottom left to the top right. The job is to find the straight line through them. A line is y equals w times x plus b. That is a slope and an intercept. Fitting means choosing the 2 numbers that pass closest to the points. This is w, the slope. It is 1 tensor starting at 0. And here is b, the intercept, also a tensor starting at 0. Requires grad equals true is the whole trick. Autograd will track w and b and fill their grad. There is no nn.Module here. A model can be this small. Now the whole program, the data, the parameters, and the loop. First, the data. We build 12 points from the true line y equals 2x plus 1, then add noise. The noise is what makes the points scatter. Next, the 2 parameters, w and b, both plain tensors, both starting at 0. And SGD, the optimizer, handed the list of w and b no dataset, no DataLoader. The data is just 2 tensors. The whole loop is wrapped in a for over the epochs, 200 epochs in all. Line 1 forward. Pred equals w times x plus b, that is the model's guess. Line 2 loss, mean squared error, how wrong the guess was. Line 3 0 grad, clear the old gradients. Line 4 backward, fill in the gradients. Line 5 step, update w and b. This is the loop from the last video, now fitting our line. This is the same ring from the last video. Forward is our line, w times x plus b. Loss is mean squared error, scoring the guess. 0 grad clears the old gradients. Backward fills in the fresh gradients. And step nudges w and b. The same loop you already know, now driving a real fit. Now run it and watch the line fit. Bad, then better, then done. Before training, w and b are both 0, so the line lies flat, far from every point. Each red segment is a residual, the gap from a point down to the line. Here they are huge. Mean squared error squares those gaps and averages them, so the loss is huge too, 29.96. 10 epochs in, the line has tilted up toward the points. It is climbing toward its true slope of 2. Look at the residuals now. They are far shorter than before. Shorter residuals mean a smaller loss. It has dropped from 29.96 down to 2.33. W is 1.499. B is 0.57. After 200 epochs, the line has settled. It runs straight through the middle of the points. The fit is done. The learned W is 1.994, almost the true 2. B is 0.843, near 1. These are close to the true line, but not exactly it. The points are noisy, so the line cannot pass through everyone. The small leftover loss comes mostly from that noise, and that is correct. One last thing, how do you read a falling loss? Read the left column. The loss falls fast, from 29.96 to 8 to 2.3 to 0.49. In the right column it barely moves, near 0.35. The curve tells the same story. Almost all the learning happens in the first 20 epochs. Then the loss settles into a long, flat tail. So why did the loss stop falling? By epoch 39, it is already within 1% of its final value. The flat tail is not a stuck run. In this run, it is a converged one. There is almost nothing left to learn once the line fits the signal. Let's bring it together. The whole model is two plain tensors, W and B, with requires grad true. Training is the 5-step loop. No nn.Module, no DataLoader. As the loss falls, the residuals shrink, and the line snaps onto the points. And here the loss flattened because it converged. The model learned what this data allows. Quick check before we go. The loss stops falling after 40 of 200 epochs and holds flat to the end. Is the run broken? Pause and predict. No, it converged. By epoch 39, the loss is within 1% of its final value. The flat tail means the model has fit the line as well as noisy data allows. But be careful. A flat loss is not always a converged run. You just built a model by hand. Two tensors, a loss, and the loop. Together they fit the noisy points. Next, we meet nn.Module, layers, and activations. It is the container PyTorch gives you for exactly this. We wrap W times x plus b into a single nn.linear. Then we stack layers with a nonlinearity between them. See you there.